Hello guys, this is Praveen and welcome to my channel. In this video, I will solve the GATE PYQs on the Greenshield model, which is a part of traffic engineering in the subject transportation engineering. But before jumping on to the questions, I am assuming that you have already studied this topic. So I will simply give the basics and the key formulas which we will be using to solve the numericals. So now I will switch on to the whiteboard, as you can see over there. So the Greenshield model, which is also called as the linear relationship model. Linear relationship between what? Between speed and density. Speed is denoted by V and density is denoted by K. Here V is, this is space mean speed. Space mean speed. And K is simply density in vehicle per kilometer. So as per the Greenshield's model, the relationship is given as V equal to Vf 1 minus K by Kj, where Vf is the free mean speed, and Kj is simply the jam density. Okay, so this is the formula number 1 and I will box it in a green box like this. Formula number 1. The second one is nothing but the substitution of this velocity in the base flow equation. What was that base flow equation? Base flow equation, it is simply Q is equal to Vk. This is another important formula which we will be using to solve the numericals. So I'll box this one as well. This is formula number 2. And if we substitute this velocity into this formula, we will get the expanded form, that is Q equal to Vf 1 minus K by Kj times K. So if I expand it, we will get Q equal to Vfk minus K by Kj, K square by Kj into Vf. And this is our formula number 3. I'll box it and 3. Now, if we differentiate this formula, this equation of flow with respect to density, that is dq by dk, and equate it with respect to 0, we will get the maxima of the flow. And by doing so, we will get a density which is equal to K equal to 1 by 2 kg. And if we put this density into this formula, we will get the value of Q, which is nothing but Q max is equal to 1 by 4 Vf kj. This is another thing to remember so that we can solve the questions directly. We don't need to derive it again and again. And if we put this density into the form equation number 1, we will get the velocity as well. That means at K equal to Kj by 2, the speed we will get is V equal to half of Vf. Okay. Apart from these 3 formulas, there are 2 more formulas, the basics formulas actually. I'll simply write them. The formula is K equal to 1000 upon S, where S is nothing but space headway. Space headway in meter. And another formula which relates the flow with respect to the time headway, that is Q equal to 3600 upon H. Here H is the time headway. Time headway in seconds. Okay, so I'll box these 2 formulas as well. This and this. This is our formula number 4 and this is our formula number 5. So this much of review is sufficient to solve all the problems which we are going to solve now, and all of them has been asked in GATE examination. So I'll jump on to the first question, which is right over there in front of your screen. Question number 1. It says the free mean speed is 60 km/h on a given road. The average space headway at jam density on the road is 8 meter. For a linear speed density relationship, the maximum flow in vehicle per hour per lane expected on the road is, and we have 4 options. This question was asked in 2024, Site 1, 2 marks. So the underlying thing in this question is linear speed density relationship. That means they are talking about what? Greenshield model. Greenshield's model. And we already know that the maximum flow, they want the maximum flow. The maximum flow in Greenshield model is simply 1/4 Vf kj. Now Vf is already given as 60 km/h. So I'll simply write Vf is equal to 60 km/h. But kj is not given. But to find the kj, they gave us the space headway equal to 8 meter. So we will use the relation between k and space headway, which is k equal to 1000 upon s. That means at kj, the space headway is given as 8. So this is the jam density. So we got both the values, Vf and kj. We put both of these in this formula, and we can simply calculate the Qmax. So Qmax will be 1/4 times Vf, which is 60, times kj, which is 1000 upon 8. This will cancel out as 15. Now I will simply use the virtual calculator, which they provide in the GATE examination as well. So this is a virtual calculator. Simply putting the values 1000 into 15 divided by 8. So the answer is 1875. It comes out to be 1875 vehicle per hour. That means the correct option is option A, 1875. Quite an easy questions. Now let us move on to the next question. I'll remove the calculator. So the second question is this one. A plot of speed density relationship, linear, of two roads, road A and road B, is shown in the figure. This is a figure which we have. If the capacity of road A is Ca and the capacity of road B is Cb, what is Ca by Cb? Now, again, the underlying term is speed density relationship is linear. Okay, linear means it is Greenshield's model. Greenshield's model. This is the first thing, and the second thing is this capacity, Ca. I have already told you that capacity is nothing but Qmax, that is the maximum flow. So in Greenshield's model, the maximum, so they are simply asking the ratio of maximum flow of stream or road A and road B. That's what they are asking. Now for the road A, this is the road A. UA, this value UA is simply the free mean speed for road A, and this UB is simply free mean speed for road B. Okay, and similarly the Ka is simply the jam density for road A, and Kb is simply the jam density for road B. Why? Because the jam density is the density when the speed reaches 0. So at this point the speed is almost 0. That means this is the jam density for road A and similarly for road B. Whereas the free mean speed is nothing but the speed when the density reaches almost 0. So these are the values when the density is almost 0. That means these are the nothing but free mean speed. Now we will use the formula of Qmax for the Greenshield's model. Qmax is nothing but 1/4 Vf kj. So for road A, we have Qmax or Ca, capacity, is equal to 1/4 Vf. For A, road A was Va, and Kj for road A was Ka. Similarly for road B, we have Cb equal to 1 by 4 VB and KB. So if we divide these two terms, we will get CA upon CB is equal to VA KA upon VB KB. This is the answer. So let us match with the given options. So the correct option is this, C. Okay, direct formula based questions. And it was of, I think, 2 marks. Yeah, it was of 2 marks and it was asked in 2023 SAT1. Now moving on to the next question, we have for a traffic stream, V is the space mean speed, K is the density, Q is the flow, VF is the free flow speed, and Kj is the jam density. Assume that the speed decreases linearly with density. Which one of the following relations are correct? Again, the same thing. Speed decreases linearly with density. Linearly with density. That means it is a question of Greenshield's model. Greenshield's model. And they are asking us for the relation between the flow and density plus flow and speed. If you notice carefully all these options, the relations are given in terms of two variables. One in terms of the density and the other one in terms of the speed, and both are with respect to the flow. So we will simply calculate it. We know that the flow in the Greenshield's model is given as VFK minus VF by Kj times K square, and this is with respect to variable K. So if we match the options, this one is correct, this is wrong, option A is wrong, and option B is correct. Now with respect to V, we need to establish this relation. How are we gonna do that? We know that the speed density relationship in the Greenshield's model is given as V equal to Vf 1 minus K by Kj, and the base flow equation is Vq equal to Vk. Putting this, no, don't put it. First resolve this equation. I'll simply rearrange this equation. V equal to Vf minus Vf K by Kj. I've opened the brackets. Now rearrange it. Multiply Kj on both sides. We will get V Kj minus Vf equal to Vf Kj minus Vf K. Divide by Vf and take K on the left hand side. So we will get K equal to Kj minus V by Vf times K. Okay. Now put this value of K, V minus Vf times Kj. Okay. Now put this value of K in this base flow equation over here. We will get implies Q equal to V times, what is the value of K? Kj minus V by Vf times Kj. Expand it, we will get Q is equal to V Kj minus V square Kj by Vf. This is the relationship between the flow and the speed. So simply match the given options. This is matching with option D. Vkj minus Kj by Vf, V square. So option D. That means the correct answers are option B and D. Okay, simply it was nothing but substitution based question, and if you knew the formulas, you can simply solve it. Now moving on to the next question, we have this question number 4. Assuming that traffic on a highway obeys the Greenshield's model, the speed of a shock wave between the two traffic streams P and Q as shown in the schematic is, it is a numerical answer type question, and they gave us two streams. This is stream P and stream Q. Now the new thing over here is the speed of the shock wave. There is a formula for this. The speed of the shock wave is given as change in flow upon change in density. Flow is already given for both the streams and speed is given, not the density. So we need to find the density for both the streams. So we will use the relationship Q equal to Vk, that implies K equal to Q upon V. Okay, so for stream P, we have flow equal to 1200, speed equal to 60 kmph. This is a 1200 vehicle per hour. From these two, we will get the density Kp equal to flow upon speed, that is 1200 on 60. This is 20. And for stream Q, again, flow is given as 1800 vehicle per hour and speed is given as 30 kmph. Putting these two into the formula, we will get the density for stream Q is equal to 1800 upon 30, that is 60. Okay, so now we got all the values which we gonna need to find the speed of the shock wave. So putting these values in the speed of shock wave, we will get in the formula of speed of shock wave, we will get speed of shock wave is equal to change in flow upon change in density. That is, change in flow is simply flow of Q minus flow of P upon change in density is simply density of Q minus density of P. Putting the values, we will get 1800 minus 1200 divided by 60 minus 20. This will be 600 upon 40 and it will be simply 50. So the answer of this question is 15. This is the speed of the shock wave. Okay, the only new thing in this question was this formula, the speed of shock wave, which is simply change in flow upon change in density. This question was asked in 2022 and it was simply 1 mark question. Now moving on to the next question, we have question number 5. This question was asked in 2022, set 1 and 2 marks. So the question says, consider the 4 points P, Q, R and H shown in the Greenshield's fundamental speed flow diagram. This is the diagram. Denote their corresponding traffic densities by Kp, Kq, Kr and Ks respectively. The correct order of these densities is, so we need to find the order of densities corresponding to these points P, Q, R and S. So first of all, let us calculate what will be the maximum density among all these 4 points. We know that the maximum density occurs when the speed approaches 0, almost 0. So in this case, the point at which the speed is approaching almost 0 is this point. Is point P. Because at this point the speed is almost 0, or you can say 0. That means this point will have maximum density. And this maximum density is nothing but the jam density. Okay. That means among all these 4 points, the maximum density will be of point P. So let us see if we can eliminate some options. Maximum density is, this is correct. This is wrong. Wrong. Question solved. We don't even need to calculate the other 3 densities because we have already solved it by the option approach. But still we can find the remaining order just for our knowledge. So for that, I will draw this diagram again. We will solve this with the graphical method as well. So I'll simply copy this diagram, paste it over here like this. Okay, now we will be solving it. To find the remaining order of the density, we will solve it. Although we have already solved this question, but just for understanding, I am solving it. I'll draw the relation between the speed and density in the Greenshields model. This is the axis. On the y-axis we have the speed. Now on the x-axis we have the density K. So as per the Greenshields model, this relation, this graph goes like this. At this point it is the free mean speed Vf, and this point is corresponding to the jam density Kj. So if we simply match these points, we can get the corresponding densities order. So at point S it is Vf, at point R it is somewhere over here, at point Q it is almost in the middle, and at point P it is simply Kj. If we extend it in the downward direction, we will get like this. So this Kj is simply Kp, which is the maximum. This Q point is over here, this is Q, so this is Kq. This R point is here, so this is Kr, and this S point is over here, so this is Ks. We can see that the relation is like this: Kp, then Kq, then Kr, then Ks, and it is matching with our option 1. You can cross check. So this option is correct. Moving on to the next question, we have this. Question number 6, 2021, sat to 1 marks. The question says, relationship between traffic speed and density is described using a negatively sloped straight line. If Vf is the free flow speed, then the speed at which the maximum flow occurs is. Again, the underlining thing is negatively sloped straight line. Straight line means nothing but linear relationship. Linear relationship. And linear relationship is nothing but Greenshields model. Greenshields model. And in Greenshields model, the maximum flow Qmax, which is 1/4 Vf Kj, occurs at density K equal to Kj by 2 and speed V equal to Vf by 2. We have already seen at the beginning of this video. So the correct option is option C. Okay, direct formula based question. Moving on to the next one. Yes, question number 7. Guys, this question is really special. Although it's not very difficult one, it was asked in 2021, sat 1, 2 marks. It's not a very difficult question, but it is a very special question, and that's why I am skipping this question for part 2 of this video series. And why I am skipping it, you will know in the next part itself. Okay, so I am skipping this question. It's a really special question. You will know why in the part 2 of this series. So don't forget to watch that video as well. Now I am moving on to the question number 8. The flow density relationship of traffic on a highway is shown in the figure. This is the figure. The correct representation of speed density relationship of the traffic on this highway is, these are the 4 options. As you can see, this diagram, the given diagram is made up of 2 parts. First, let us name it A. Let us name it point A. This is point A. This is point B, and this is point C. So there are 2 portions, portion A and B and portion B and C. So we need to analyze both this portion to get the correct relationship between speed and density, because the given graph is between flow and density, and we need to find the graph between speed and density. So let us analyze both the parts step by step. First, the part AB, the portion AB. If we write the equation of this portion or this line AB, We'll use the equation of straight line as y equal to mx plus c. So for this portion, the intercept is 0 because it is passing through the origin, and this is origin. Let us write it over here. This is origin. Intercept is 0, and let us call the slope as m equal to m1 plus m1 because it is positively sloped. So it will be plus m1. So the equation will be using this equation. Let us call it equation 1. So using this equation we will get y here. This y is flow. So q equal to mx here, x is density, k, flow is q, density is k. So mk plus c is 0. So this is the only term which is remaining. Okay, this is the relationship. Let us call it as equation number 2. And we already know that the base flow equation is q equal to vk. This is the base flow equation. Let us call it as equation number 3. Let us renumber this equation. This is equation 1, this is equation 2, and this is equation 3. Okay, if we compare equation 2 and 3, we can conclude that the speed is m, and m, we already know that the slope of this line is constant. The slope is not changing for this line. That means m is constant. That means the speed for this portion AB is also constant by comparing these two equations. So we can use this information to eliminate few options. Those options in which the speed is not constant in the beginning. So as you can see in option A, it is constant. In option C, it is also constant. In option D, it is also constant. But in option B, it is constant, continuously decreasing. That means this option is already eliminated. Now we are left with 3 options. Now to find the remaining part, we need to analyze the portion BC as well. So I'll do that over here. Portion BC. Again, we need to find the intercept and slope. To find the intercept, if I extend this line backwards, let us say like this, I'll get a point over here, and let us call this intercept as C. Okay, and since the line is like this, so it has a negative slope. It is negative slope. Using these two data, I will write the equation of the line BC as y. Y is simply q equal to mx. Here it is negatively sloped, so I will write as minus mx. X is simply density, mx plus c, the intercept c. Okay, and we already know that q is equal to vk. So putting the value of flow in the equation of BC, we will get, just replace q as vk is equal to minus mk plus c. Okay, divide both the parts with k, we will get both the sides with k, we will get v equal to minus m plus c by k. This is plus. Let us call it as equation number 4. So as you can see, this equation represents an equation of rectangular hyperbola. That means for portion B, the relationship between speed and density will be of rectangular hyperbola. That means we can eliminate this option as well, option D as well. Why? Because in this option, the portion BC is straight line. But we have already concluded that this portion has to be rectangular hyperbola. So this can't be the answer. So now finally we are left with 2 options, option A and option C. Both are representing a rectangular hyperbola for the portion BC. Okay, I will simply name here as well A, B, C and A, B, C. Now, the only difference between these two curves of BC is the slope difference. That is, at point B, the option has like almost infinite, almost a 90-degree slope, and at point C it has almost 0-degree slope. Whereas in option C, at point B it has almost horizontal or 0-degree slope, or at C it has almost 90-degree slope. That means now we need to find the equation for the slope of this curve. So how we gonna do that? We know that the slope of any equation is simply we can get by differentiating it. So I will differentiate this equation number 4 with respect to the density K, that is dV by dK. That means the slope is equal to dV by dK will be, this m is constant so it will cancel out, we will get minus C upon K square. Okay. Now we need to find the slope at the critical points, either at B or at C. I will calculate the slope at point B. So at point B, the density approaches 0. That means as we move leftwards, the density is approaching 0. The K value is approaching 0. So in this slope equation, when K approaches 0, the slope approaches minus infinity, because as K tends to 0, this whole term it approaches minus infinity. The minus infinity can also be treated like as a slope of 90-degree. Okay, that means we can conclude that as soon as we go on the left hand side, the slope reaches to 90-degree. We can use this information to find that the correct option is option A, because only in this curve, when we are going leftwards, the slope is approaching almost 90-degree. Whereas in this option C, when we are going to leftward, I'll use the red pen for this one. When we are going leftwards, the slope is almost approaching 0-degree. This is 0-degree slope. That means this option is wrong and option A is correct answer. It was a little bit a lengthy question, but it was not difficult if we solve it using the portion approach. Portion A, B and BC. And it was asked in 2020, set to 2 marks. Okay. Now moving on to the next question, we will have question number 9. The speed density relationship of a highway is given as U is equal to 100 minus 0.5 K, where U is the speed in km per hour, K is the density in vehicles per kilometer. The maximum flow in vehicles per hour round up to the nearest integer is. This question was asked in 2019, set to and 2 marks. Now there is nothing given as the linear relationship between the speed and density, but they provided us with this equation, U is equal to 100 minus 0.5 K. And from this equation we can conclude that the speed is directly proportional to the density K. Directly, or you can say linearly proportional to the density K. That is, there is a linear relationship between what? Between speed and density. And linear relationship means nothing but Greenshield's model. Greenshield's model. And for Greenshield's model, we already know that the relationship between speed and density is given as V is equal to Vf 1 minus K by Kg. If I expand it, we will get V is equal to Vf minus Vf by Kj times K. If I number this equation as equation number 1 and this is equation number 2. So by comparing equation 1 and equation 2, from equation 1 and 2, we can conclude that Vf, the free mean speed, is simply 100 km per hour and Vf by kj is this 0.5. Vf by kj is equal to 0.5. Put the value of Vf over here, we will get 100 upon 0.5 is equal to kj. That means the jam density kj is equal to 200. Okay, now they are asking us the maximum flow. So for Greenshield's model, we know that the maximum flow Qmax is given as 1 by 4 Vf kj. We already got the values. This is Vf and this is kj. So putting it in the formula, we will get 1 by 4 times Vf. Vf is 100 and kj is 200. This is 50. That means Qmax is equal to 5000 vehicle per hour. So the answer is 5000. Okay, quite an easy question, direct, straightforward, formula based question. So that's all for this video, and I hope you liked it, and I have left some questions for the part 2 of this series, so don't forget to watch those. Until then, keep going.